This is section 4.4, part 4. We are now going to solve a quadratic equation. So, this is very similar to what we did in section 4.3, but in 4.3 the equation was already set equal to 0 for us. Sometimes you'll see an equation where it's not set equal to 0, but you'll know that you want to find your zeros or find your roots, which we talked about in 4.3, because you have an equal sign. All the previous problems were just expressions. There were no equal signs, so we just factored, got it to a simple form, its simplest form, we were done. Alright, when you have an equal sign, you want to solve for your variable. Alright, so because you're going to have an equation. So the first thing I want to do is just combine my like terms. So I've got 11x and 3x, and then I also have 8 and 4. I want to combine those, and I'm going to bring the 3x over and the 4 over because I want this equation equal to 0. My goal is to have nothing on one side of the equal sign. So I'll start by subtracting 3x. So I've got 4x squared, 11x minus 3x. It's going to give us positive 8x. And then I'm also going to subtract over 4, all in the same step. So 8 minus 4 is 4. So I've combined my like terms, and I have 4x squared plus 8x plus 4. So 4.4, I've got a leading coefficient of 4, so it kind of looks like I'm going to have to find the factors of 4 times 4 that add up to 8. But wait, I see that 4, 8, and 4. There's a common factor there. The GCF, the greatest common factor, is the one you want to go with, and that's 4. So it looks like I can factor 4 out. And I'm going to get x squared, 8x divided by 4 is 2x, 4 divided by 4 is 1. So it looks like I have now a 4.3 type problem, where I just have to find the factors of 1 that add up to 2. So the factors of 1 that add up to 2, well, that's nice and easy. That's 1 plus 1. 1 plus 1 is 2. So I've got 4x plus 1 times x plus 1, which is equal to 0. And I've got x plus 1 written twice. So whenever you see that you have the same binomial written twice, what that's really telling you is that you had a perfect square trinomial. Square root of x squared is x, square root of 1 is 1. So this is the same thing as having x plus 1 squared. Alright, doesn't matter which way you do it, alright, but you're going to get the same answer. So I'm going to set each piece equal to 0. So if I've got one term here, which is 4, then I've got a second term here, which is x plus 1 squared. Alright, you really only have to set the x plus 1 equal to 0 once, because you're going to get the same answer, and we talked about that before. If I set 4 equal to 0, that makes no sense, so you can literally just drop that out. You're just worried about the variable. So I'm going to set x plus 1 equal to 0, and I'm going to get an answer of negative 1. Alright, let's go down, try one last one. Alright, where we've got 25x squared is equal to 9. Remember, you want to make it set equal to 0. We have no like terms, so we can't combine them, but I can bring the 9 over. 9 minus 9 is 0, so I've got 25x squared minus 9. I set the equation equal to 0. Now I'm ready to go. Alright, so it looks like I have a binomial with subtraction, but I don't have perfect squares, or do I? Alright, what's the square root of 25x squared? Well, 25 looks like a perfect square. X squared is a perfect square, so I take the square root of that, and I get 5x. What about 9? Is that a perfect square? Square root of 9 is 3. So this is my difference of two squares, and I did this before, but I'll do it again. A squared minus b squared is going to be a plus b, a minus b, where 5x is your a, 3 is your b. So this can get factored into 5x plus 3 times 5x minus 3, set that equal to 0. Two binomials, set them each equal to 0, and then solve for x. So I've got 5x plus 3 equals 0, 5x minus 3 equals 0. I'm going to subtract 3 over, and I get 5x equals negative 3. Divide by 5. X equals negative 3/5. There's one of my roots, one of my zeros. Add 3 to both sides, and I get 5x equals 3. Divide by 5. 5x equals 3/5. And there's my second zero, or my second root. And you've successfully solved this quadratic equation. Alright, that's the end of 4.4.